Hello and welcome to this OCR Further Maths Statistics video. This is the first in a series looking at chi-squared tests, beginning with constructing contingency tables. We'll start by looking at the first question posed here. Is there any connection between hair colour and eye colour? This type of data is clearly qualitative. We'd call this categorical data. There's nothing we can measure, but we can categorise eye colour and categorise hair colour. So how can we investigate whether there is any association between two such variables? We're going to look at what's called a chi-squared test. You may have come across the chi-squared test for association if you study A-level psychology. It's a very important test used in cases where the data is qualitative rather than quantitative. The first step is to put our variables into a two-way table, or a contingency table like this one. The categories are black, blonde, brown, red, and it's very common in a contingency table to have an other category. Not everybody necessarily falls into the obvious categories, so there is an other category in each of these two variables. We need to be able to categorise everybody in our sample. And also notice that we have a column and a row for totals here. If you have to calculate these totals for yourself, always check that the totals for your rows and the totals for your columns add up to the same overall grand total. Here we have a sample of 131 in total. We refer to the boxes in the table as cells, so in this cell here we can see that 7 people have black hair and blue eyes. Here's another example of a contingency table. Sometimes our data may be quantitative, so that it could be grouped into categories. For example, here we have GCSE grades, but we've grouped them into categories 1 to 3, 4 to 6 and 7 to 9. And notice that there must never be any overlap between the categories that you choose, otherwise some people might get counted twice. Again, notice that we've got totals and that the totals for the rows and the totals for the columns both give us our overall total of 83. So there were 83 people involved in our sample. When we want to analyse the data we have in a contingency table, we compare two sets of values or frequencies. First of all, we have the observed values O, which are the actual frequencies of the data gathered, the numbers in our original contingency table. Then we compare those with the expected values of frequencies. What we'd expect to get if there was no association between the variables. This is the theoretical situation. We want to see if there is any difference between our data and what we'd get in theory if there is no association. To calculate these frequencies, assuming no association, we need to assume that the two variables are independent. We'll then use the laws of probability to work out the expected frequencies. Here's a quick reminder of a couple of important probability theory points. First of all, if we have experimental probability, we can only get a probability for an event by looking at what had happened in an experiment. Here we have a biased die, and we obtain 8 sixes out of the 30 times we rolled. That would give us a probability of getting a 6 of 8 out of 30 from the data that we have. This is just the proportion of time that we got a 6. We're then asked how many 6s would be expected in 100 such rolls of this die. So we multiply our proportion, or probability, by 100. So we'd expect 8/30ths times 100, or 26.7 sixes. The second little reminder here is that if A and B are independent events, then the probability that A and B occur is just the product of the two probabilities, the probability of A multiplied by the probability of B. Here we have our contingency table with our observed values, or frequencies. How can we work out the expected frequencies, assuming that hair colour and eye colour are independent events? Well, If we look here, we had 7 people with blue eyes and black hair. How many would we expect if hair colour and eye colour were independent? Well, let's have a look first at the probability that a person has blue eyes. Well, we estimate that from the data that we have. And there were 40 people with blue eyes out of a total of 131. So the probability for having blue eyes is 40 out of 131. And the probability that we would get black hair is 29 out of 131. So the probability of obtaining somebody with blue eyes and black hair would be that product. That's our probability. So how many people would we expect to have blue eyes and black hair? Well, as we did before, we multiply our probability or proportion by the sample size, which is 131. And that gives us 8.85. It's very important at this point to realise that these are just expected values. They're theoretical. They're not going to come to integers, and you shouldn't round them to integers. In general, theoretically, we would expect 8.85 people out of 131 to have blue eyes and black hair. Notice that our probability here multiplied by the grand total can be simplified. You can see that we simply have the row total 40 multiplied by the column total 29 divided by the grand total. And that's how our expected frequencies will be evaluated. So the routine is draw out another contingency table, put all the row and column totals in, but not the individual cell values. Now calculate the values for each of the cells. So blue and blonde will be 40 times 22 over 131, which is 6.72. And other will be 23 times 28 over 131, which is 4.91. Pause the video while you fill in a few more cells. There's no need to do all of them though. OK, these are the values that you should have got. It's always worth doing just a bit of mental arithmetic to check, for example, that your top row does indeed still add up to 40. Because obviously we've used those totals, so that should still add up to 40. And similarly for the other rows. And that your columns add up to the correct column totals. Of course, it might be slightly different because of rounding errors, but you should have got more or less the total that we're supposed to have. So, in summary, to calculate an expected value or frequency from a contingency table of observed values, you simply multiply the column total by the row total and divide by the grand total. That's the end of this introduction to contingency tables. In the next video, we'll look at how to set up a chi-squared test on a contingency table.